that is antibody 1, and that is actually biosensor is ready for your detections. And if you drop some solution, your antigen, that is a target which you have, so it will bind on the surface, then we will wash the surface. Then on that surface, then you can again drop some secondary antibody that conjugated with some AU, means the gold nanoparticle, and that nanoparticle now can bind on the surface. So this is kind of the sandwich with the target. The primary antibody, then your target, then the secondary antibody. So secondary antibody that conjugated the gold. So this is the sandwich will form. Now we will add some chemical like sodium borohydride NP. NP means nitrophenol. So when you will add this nitrophenol and the sodium borohydride, they will react with the gold nanoparticles. So if gold nanoparticle absent, then this nitrophenol cannot be converted to the aminophenol AP. So for this, we need gold nanoparticles. This gold nanoparticle we need. So after if you have gold nanoparticle, then nano NP will convert it to the AP, and then this AP will react with Fc plus. This is kind of iron compound, ferrocene, and it will actually ferrocene plus means it is actually oxidized form. You know the oxidation and reduction, right? Oxidation means when some compound oxidized means it will release the electron from lower oxidation state to higher oxidation it will form. So Fc plus means it is already released one electron. So when Fc plus means higher oxidation state will react with aminophenol AP, so it will form a lower oxidation state, that is Fc, something like Fc0, means lower oxidation state. So, and this AP will react Fc plus means it will Fc plus itself will reduce to Fc0 and AP will oxidize. So Qi, the quinonimine, it is the oxidized form. It is actually oxidized form. And AP is the reduced form. So because of this reaction, the electron will transfer to the transducer ITO, this electron. So this electron will measure. Okay, this electron will measure. Actually, if you have many gold nanoparticles, then we will get so many electrons. The number of the electron actually proportional to here. I mean, how many AP is forming. So AP, you will get so many AP if there is so many gold nanoparticles. So how you can increase the gold nanoparticles? If you have more target. So if your target concentration increase, if your target concentration increase, you will get more gold nanoparticle. If you get more gold nanoparticle, then more AP will form on the surface, and more AP means more electron transfer on the transducer. So your output, that is called in the form of like current or charge, that will be increased. So if the target concentration increase, you will get more current, more charge. So this everything, there is some term also there that is called redox cycling reaction. This reaction. So that reaction actually I will explain again after some maybe after a few slides later. I will again discuss. Actually, something like this reaction, it can be done on the surface. Not only this reaction, similar kind of many reaction we can think. So in this case, one reaction like this, where we can change iron, we can put here some other metal ion, something like this. So I will teach you how we can choose this kind of the chemical component. See here, quinonimine in the solution you already have sodium borohydride, right? Because aminophenol is oxidized to quinonimine, it can be converted to the aminophenol again by the help of sodium borohydride. So this kind of cyclic reaction can be going on the surface, and you will get more and more number of the electron on the surface. So this is kind of your in the right hand part, this is kind of the chemical reaction. In the left hand part, this is kind of your biological things or biosensor part here. In the left hand side is the biosensor part here. So like this way, we can what you can say that we can form, or like this way we can develop a biosensor We can detect some disease marker like this way. So first of thing, you have to develop a sensor on the surface. How we can develop a sensor on the surface? By the help of some antibody antigen binding like this way. And the right hand side, we can design some chemical reaction. So in the right hand, we can generate some chemical reaction, and that chemical reaction we can decide how we can design these things. That can be done slowly. So you can see then if we increase the target, we will get the higher and higher current output, and we can predict the concentration of the target in the solution. So this is just some preliminary idea I am giving you. I will discuss more details again. Okay. So is it clear?
Sir,
Tell me.
sir, actually, this conversion from aminophenol to quinoamine, why is this process should go directly? Why are we just increasing the number of conversion from this thing? What is the purpose of this thing? I'm not able to understand.
Okay. Yes. Which one? Okay. So you are asking that aminophenol to quinonamine can be converted directly.
So this reaction is just a side reaction. What is the purpose of this reaction? I didn't understand this thing, because in the solution we are taking Fc plus, and in the presence of Fc plus, aminophenol will generate one electron. So so all these things are easy. Then this step, an extra step, why it is being performed here, or how it is, rather how it is uh, of our use.
See, here actually you can see this reaction. See, aminophenol, first of all, AP is the aminophenol. This should be generated on the solution in the surface. You will be provided NP, nitrophenol. Okay, so this nitrophenol somehow you have to convert. You are right that aminophenol can. This is not the side reaction. This is actual reaction in the biosensor. Now, if in your solution, if you have aminophenol, then only it will react with the Fc plus and it will form the quinonamine. So because of this reaction, the electron will be generated. So this electron transfer will be done only if aminophenol presence, and if aminophenol concentration is very, very high, so this reaction rate also will be increased because of the higher concentration. So how we can generate the aminophenol on the surface? So this is actually a main reaction, not the side reaction. So this aminophenol can be generated from the nitrophenol, NP. So actually, when you will detect the biomarker, you will be provided nitrophenol, NP. Okay, this nitrophenol now will react with the gold, and so in your surface, gold should be there. If there is no gold, then your solution will have the nitrophenol, and this nitrophenol will not react with Fc plus. This reaction not possible. This nitrophenol cannot react Fc plus, but only aminophenol can react. Okay.
Yes,
Now,
sir.
now what happened? This nitrophenol conversion to aminophenol only possible. Then gold should be there. So how you can come? How gold can be immobilized on the surface? That is because of the antigen antibody binding, right? If there is
Yes.
antigen there, then secondary antibody conjugated gold will bind. Then
Yes,
you
sir.
will get gold. If there is no gold, then no this reaction. If there is gold, then this conversion will possible. Now, if there is higher concentration gold, then so many NP will convert to the AP. Means AP concentration will be increased, and more AP means high. You will get this number of electron transformation is proportional to the concentration of the AP, and
Yes, sir.
proportional to
Exactly.
the concentration of gold. Means number of
Sir.
catalyst also increasing.
Yes, sir.
Clear?
Yes, sir. So, but our aim is to generate the electron current. In speaking directly about this, we are concerned with
Right.
this electron.
Right. You are true.
So,
Our main
so
goal, anyhow, we have to generate the electron, and you have to increase the number of the electron.
Yes.
If you can increase number of the electron, then signal to background ratio will be increased, right? Means I mean, this is because of signal, right? If there is more antigen, then more gold will be there. So this is called the signal. Hmm. So background means if there is no gold, means there is no target, then gold cannot be immobilized on the surface. Then whatever you are getting the current by the help of nitrophenol and Fc plus, that is background, because Ap will not be there, Ap absent. So in the absence of Ap, because of Np and Fc plus, you will get somewhat little bit current. That is called background current. And what is the signal? Signal is after immobilizing the target, you will get gold, and whatever current you are getting, that is signal. Because of this conversation, you will get a higher amount current than background. Clear?
Sir, did we employ any other reaction mechanism other than this
Yeah,
nitrophenol
yeah, yeah.
use?
That's I'm asking. That now I will. This is just preliminary idea I'm giving you. Then I will take a special few classes that how we can think about this kind of reaction. So you can now design by yourself. Instead of MP, maybe you can use some other chemical. Instead of Fc plus, maybe you can use some other metal, metal here, ion here. So that I will guide you slowly. Okay, that you will get. Just take few more classes. Then I will teach you all the steps. Huh? This is just a preliminary idea I'm giving you. Just think about it. Okay. Just a moment. So okay, now this is so this is the bias and okay. So now as I mentioned that I will teach you today how we can immobilize this linker on the surface, right? That will help you to binding the antibody, basically, right? So this is the immobilization method I will teach you now. Say, okay, students, just 1 minute. So I will talk to you. Just 1 minute. Okay, sorry. So someone came to my office to talk to me, just for some information. That's fine. Uh, okay. So is it audible, right, guys?
Yes, sir.
Yeah, you can see the slides. This is the bioimmobilization technique. So how we can immobilize our antibody on the surface. That I said here in this slide, that antibody can be immobilized by using some linker. So let's see, what is the linker? So one information just I'm telling you that primary antibody, just I'm saying here, this primary antibody, it contains lots of free amine group. You know, amine means NH2. It contains lots of free amine group. Also, it has lots of free carboxylic group also. Carboxylic means COOH. So in this class, some of are you from electrical department, mechanical department. So just you can raise your hand and ask me some questions that if you don't understand, because I think the 10th plus 2 level, you already have some biology or chemistry, so you know what is the amine group, what is the carboxylic group, right? I'm not going to explain that one. So amine group means NH2 group. So primary amine means this primary antibody, it will contain lots of NH2, free NH2. Means you can work on that free NH2 group. So you can show that you can functionalize them, and not only functionalize. So by the help of that amine group and carboxylic group, you can activate them and you can use them for immobilization on the surface. So this is the thing actually I'm going to teach you today. It is very interesting. See here in this slide, you can see this one, COOH. This is the carboxylic group, and one means you can say this is actually some surface. Means you can put ITO. So ITO is a transduction on that surface. You are going to immobilize primary antibody. So somehow on your surface you have to generate some carboxylic group, COOH. Okay. So this COOH group you have to generate on the ITO surface. So how you can generate COOH group? So that also there is some chemical process. I will tell you that first we will create some carboxylic acid group on the surface, and then we will activate that carboxylic acid group with some chemical like EDC. So EDC is the full form. The name is N3. This one N3 dimethylaminopropyl. This N prime ethyl carbodiamide. So no need to remember the full name. Just you can say EDC. EDC is the just abbreviations here. So if you can activate the COOH group by reacting EDC. So just we can mix this one, these two together, then it can form something like this complex with the carboxylic acid group. Now, see number two. Number two is your primary antibody that I mentioned. So antibody already contain some free amine group. Just I mentioned the primary antibody it contains some free amine group. So this NH2 now will react with this complex. So there is a lone pair electron. So this will react. Now it will attack here, and this actually some big this molecule actually it has the high leaving aptitude. So it will leave. So this compound, the right hand side you can see this one it will leave, and number two this one that is primary and your antibody it will bind with your electrode surface. So one is your electrode surface that is transducer, and number two is your antibody. So by chemically you can immobilize some antibody on the surface. Okay, I am just repeating again. So number one is your transducer surface. So you have to generate some carboxylic group on the surface. So how that I will tell you. First, just guess on your surface you have COOH group. Okay. Now this COOH group can be activated by this EDC. Okay. So this group actually see COOH group and amine group. So you can think about why I am using the EDC. Instead of using the EDC, you just can mix together. Carboxylic acid content this number one and number two. They can react together, right? And it can that two one and two that can combine. Actually, this one and two reaction actually thermodynamically okay, feasible, but kinetically these two reaction means carboxylic acid and amine reaction is very slow. I mean the kinetics saying it is very slow reaction, but thermodynamically they are okay. So to make this reaction faster, you need some chemical. So which chemical you need? Some EDC, this chemical. So when you are adding this EDC with this COOH, it will bind, and because of this large compound leaving aptitude is very high, its leaving aptitude is very high. Because of high leaving aptitude, this amine group can react easily and this will leave. And 1 and 2 can bind together. So that's why so you will get actually primary amine group on the electrode surface like this way. Clear, guys?
So does this primary amine group comes from the antibody or?
Yes, the primary amine group that actually it has some pre-amine group. Primary antibody already contain some free amine group. So if you see the structures of the some antibody, so it has some primary amine group.
Yes, sir, I understand, man. That's a peptide bond or those kind of things. So there are
Right.
amine groups. So this primary amine groups is coming from the antibody. That's why I wanted to confirm that thing.
Right. So
Okay, okay, okay.
so what is your
Yes,
background?
sir.
So you're from biotechnology, right?
Chemical engineering.
You're from chemical engineering. So yeah, you
Yes.
are true. So that primary amine group actually coming from the primary antibody surface. So you can utilize that primary amine group. So
Okay.
when you are you have to some just you have to create on the electrode surface some carboxylic acid group. That is your work first. First work you have to treat the electrode surface with some chemical. That chemical I will let you know. So just chemical, then your surface will be carboxylic acid group will be there. Now you just drop the EDC and primary antibody solution together. Then they can bind together, and you can wash the surface. Then primary amine group will be on the surface. That's all. Very simple.
Okay, sir. Okay, sir.
Huh? So this is one
Yes, sir.
one method. This is one method. In the next slide, I will show you again. So it is clear, right? Everyone. So who are not from biology or who are from the mechanical or electrical, is it fine? Is it very simple, right? Is it clear? Hello, guys. I can see here almost 46 students here. I think some of you are from electrical or mechanical. So is it okay for you? Or can I can repeat for you? Hello. I'm not getting anyone. I'm not getting any response from you.
Sir, you can move on.
Uh,
So
okay, it's clear, right?
yes, sir.
Yes.
Yes, it's
Yeah,
clear.
yeah. Please let me know. Otherwise, I'm just because I can't see you. So sometime maybe it is not. If it is not understandable, maybe it can make problem that you will not understand the whole class then. So I want to make this online class more effective. So I have to interact with you, and you should interact with me. Okay. Now see the another method. So as I said, the EDC one chemical. See carboxylic acid group. So if you mix the EDC, then it will form this complex. Now you can add primary amine here one step, but instead of this, you can add sulfo NHS. That is another chemical. So why I am telling that instead of adding primary antibody, you can add the sulfo NHS and then antibody, because sometimes people like this reaction to make it more faster. I mean, how you can make faster reaction means this complex when you make with the EDC, if you react with the sulfonation, its leaving aptitude is much faster. So if you react, I mean EDC plus sulfonation means NHS, these two chemical together first, then it will form something like this complex, the bottom one, last one. So this complex leaving aptitude with the primary antibody amine group is very fast. So this will react this, and this sulfur NHS and this leaving side will remove, and you will get the primary antibody on the carboxylic acid group surface electrode is much faster. It will, and this conjugation will be more effective than only EDC. So you can use only EDC, or you can use EDC plus NHS or sulfur NHS. So these two chemical actually help this amine binding, means primary amine, that is all the antibody. This binding make it much faster. Nothing else. Just the reaction will be much faster. Okay. So instead of using EDC, you can use also EDC plus NHS. Just this information. Okay, guys. Now, yeah. So how we can make the carboxylic acid group on the surface? So let's come this point. So for making the carboxylic acid group on the surface, you can first treat the surface with some oxidizing agent. So how we can make it? So one thing, so on the surface, actually today, wait, where is the pen? Today my pen is not working. Let's see, pointer, pen, right? Yes. See. So on the surface, what you can do, you can immobilize some nanoparticle first. So now we are coming how we can form COOH group on the surface, right? So this is your ITO surface, ITO. So this is your ITO transducer. So on the surface, we are immobilizing some nanoparticle. Immobilizing means we can drop cast. Drop cast means you can make some CNT. CNT full form is a carbon nanotube. So this is the kind of carbon nanoparticles, or it is like tube-like structure. Carbon nanotube. We are saying carbon nanotube. So we can immobilize some carbon nanotube on the surface, and we can oxidize this carbon nanotube surface by the help of some oxidizing agent, like some acid treatment. You can treat the means what you can do in a small beaker. You can take CNT, carbon nanotube, and you can add here some concentrated acid like sulfuric acid or something like this, and you can heat sometime for 10 minutes or 20 minutes, and so many carboxylic acid group will form on the carbon nanotube surface. So COOH group will form on the carbon nanotube surface by oxidation. How you can oxidize it? You can oxidize by the help of some concentrated acid. So that now that nanoparticle solution you can drop on the transducer surface. So this is the ITO surface. So in your beaker you have the carbon nanotube that already functionalized carboxylic acid by the help of oxidation. So that nanoparticle you can drop. So now you can easily, your surface become carboxylic acid group. Now that carboxylic acid group you can activate by EDC NHS. By EDC plus NHS you can easily activate. So after activating by EDC NHS, you can add primary antibody that contain amine. Clear?
Sir, can you once please explain this thing once more?
Yeah, okay. Okay, I will explain. So you want to immobilize carboxylic acid group on the surface. So you can now use the utility. Now you can use some nanoparticle on the surface to form some carboxylic acid group. So what you will do, you can take some carbon nanotube. Not only carbon nanotube, there is lots of reagent there, like graphene oxide also there. So carbon nanotube, I can show you some. Wait. I can show you the actual structure of the carbon nanotube. So you can see carbon nanotubes. Go to the images. Yeah. So it is something like this. You can see, right? This kind of tube structure. Can you see the? Is it visible? My windows. Okay.
A bit small, not at all clear.
Bit small. Yeah, it is something like this. So, and the carbon nanotube is made by carbon. So it is made by carbon. So, on that surface, if we oxidize it by acid, so some carboxylic acid group COOH will form. So not only carbon nanotube, some carbon-based nanoparticles you can use, like graphene, like graphene oxide. This is another, so something like SIT kind of structure. So graphene surface also you can form like carboxylic acid group on the surface like this way. So better the surface actually it contains somewhat C-double-H group, but you can oxidize the surface. You will get so many C-double-H group on the surface on the graphene oxide. So this is kind of SIT-like structure, and it is the nanostructure, and you can just drop cast on your electrode surface. Just drop, and you can dry it for room temperature, and then you can wash the surface. Then on the surface, you can treat the EDC NHS. So I can show you another thing that graphene oxide, right? Like EDC. I just you can search the Google also later when you study in your home or more information. You can search like this one. EDC NHS treatment, EDC NHS treatment on like graphene, graphene oxide surface for antibody immobilization. Like this way you can search. Then you will get some picture like this. Right? There is so many process you will get. Yeah, see, is it visible or very small, right? I think I can enlarge this one. Right. I think I can enlarge. Yeah, see, this is the surface, this one. You can form first C-double-H. So it will, like this way, primary amine group will bind on the surface. See, so as I said, the primary antibody actually contain NH2. Also, it contains some C-double-H group also. Both free group is there. Both these two free group are there on the antibody surface. That is, you can utilize this free group, amine or and carboxylic acid group, and you can react with these two group by DCNHs. So, if you want to utilize the amine group, then you have to form C-double-H group on the surface. But if you want to use the carboxylic acid group, then you have to form amine group on the surface, vice versa. Clear? So if you want to use amine group, then you have to create C-double-H group. Now, if you want to use the C-double-H group, you have to create the amine group. So how you can create the amine group, I will let you know.
So this carbon nanotube entity is already containing C-double-OH group.
Right. Carbon entity already C-double-H group there, but sometimes maybe it is not sufficient, right? Because of some aerial oxidation, because of that, some C-double-H group will be there, but it is not sufficient. To make the sufficient C-double-H group, you can oxidize the surface. So how we can get the more C-double-H group? One way is the oxidation. You can oxidize the surface. Okay. Clear?
Yes, sir.
You can just
Okay, so we are.
Yeah. So
we are basically using the CNT for oxidizing, for getting more and more carboxylic acid groups, right? We are oxidizing the CNT to generate more carboxylic acid, and then by EDC treatment we are further carrying it forward, right?
right.
Okay.
So yeah, just make it simple, and this is not much complicated. Yeah. So like this way we can make it.
Okay.
So yeah, like this way. So as I said that you can make it the C-double-H group on the surface. At the same time, we can make the amine group also on the surface. So how we can make the amine group on the surface? This is the way. Like APTES, one chemical. One chemical is the APTES. The full form is 3-aminopropyl triethoxysilane. So some chemical I am telling you today, but don't be afraid because of some chemical. No need to remember all the chemical name. During the exam, I will give you. Just try to understand how we can create amine group on the surface, how we can create carboxylic group on the surface, and how we can use those functional group to bind with the primary antibody and make antibody, immobilize the antibody on the surface to make the biosensor. See, so as I said, the carboxylic acid group can be done, easily formed on the surface by adding carbon nanotube, and carbon nanotube surface can be oxidized. And how can we, amine group can be formed on the surface? See, this is a GMR1 sensor. This is nothing, just a name, on sensor surface name. So no need to just leave it the GMR. Just this is the sensor surface. On the sensor surface, here you can see lots of hydroxyl group on the surface. Actually, surface is not like the bare surface. There is lots of hydroxyl group will be there. How we can make the hydroxyl group? Basically, when we are receiving our electrode from the company or from some manufacturer, lots of impurity on the surface there, like organic impurity, because of some because of contamination, lots of impurity there. So we have to remove all the impurities, right? So how we can remove? There is some way. Okay, I will just write down here by my pen. Yeah. So how we can clean the surface? So first of all, you just remember when we are receiving the electrode or transducer from any manufacturer, lots of contaminant there. We cannot use directly or immediately. What we have to do? The electrode surface we have to clean. So we need to clean the surface. So how will clean the surface? First, we have to clean some organic solvent like ethanol. So, like you take a beaker, take some ethanol, and dip some electrode. Like electrode you receive from company, you dipped on that ethanol solution. Then you have to sonicate it. Sonicate means it is a sound vibration. So you have to sonicate it around 10 minutes. So lots of organic contaminant will be there on the surface. They will be removed. And number one. Number two, after this sonication 10 minutes and with organic solvent like ethanol, you have to dip again in a beaker that contain some something like ammonium hydroxide plus H2O2, means it is hydrogen peroxide plus water. This is 1:1:5, this ratio. Ammonium hydroxide 1, H2O2 means hydrogen peroxide 1, and water means 5. This ratio you have to make a mixture. Then you have to dip all the electrodes. And again you have to sonicate. You have to sonicate it around 10 minutes. Then all the impurities will be removed from your surface, and your surface will become more hydrophilic. I think you know hydrophilic, and hydrophobic. So hydrophilic means if you drop the water, so water can easily spread on the surface. Means that is called the contact angle. So contact angle will be very, very low. Hydrophobic means if you drop the water, so it will be like spherical. You will get the very means contact angle, very large contact angle you will get, right? For the hydrophobic, you'll get large contact angle. And because of lots of organic impurity if you have your surface, then you will get the large contact angle. and your surface will be hydrophobic. And if your surface contain very less impurity, organic contaminant, then your contact angle will be very low. Your surface become more hydrophilic. So how you can make the surface hydrophilic? You have to go with this all the procedure. This one, number 1 and number 2, this procedure. You dip the electrode first in the ethanol solution, sonic at 10 minutes, and then ammonium hydroxide, hydrogen peroxide water solution, sonic it again 10 minutes. Then all the contaminant will be removed and your surface become hydrophilic. And when your surface become hydrophilic, then you will get lots of hydroxyl group like OH group on your surface, on the transducer surface. Clear, guys? Or can I repeat it again? Do you want to repeat or is it clear? Hello? Can you hear me?
Yes,
Is it clear? Is it clear?
yes, sir.
Yes, sir.
So see, I just teaching all of you. So please respond. If you don't understand, please respond. Because it's very simple. You are like the 4th year, 5th year bachelor students or some master students, PhD students are here. So sometimes I'm skipping some very simple things. But if you don't understand, please let me know. I can repeat. So like this way, we can make lots of hydroxyl group on the surface. So this hydroxyl group now will help you to form amine group on the surface. How? So that can be done by the help of this chemical APTS. APTS full form here. This is the APTS full form. So APTS one end you have the NH2 group. So if you dip your surface in this APTS solution, then this hydroxyl group will react with this APTS, and your one end that contain amine group, it will be the outer side. So like this is actually this is silicon compound. This silicon compound will bind on your hydroxyl group surface, and another end that contain the amine group, that will be the outer surface. So this will help you to bind with your primary antibody. So your primary antibody also contain carboxylic group. So that carboxylic acid group can now react with the amine group. Or there is another process. So I am teaching you so many procedures. Just you have to understand. No need to remember. Just understand. So you have the COOH in your antibody, and now you created amine group on the surface. So this NH2 and COOH can react together by the help of EDC plus NHS, right? Or another thing, you can make this reaction more effective by using another chemical, GLU. GLU is kind of chemical that is called glutaraldehyde. So this glutaraldehyde, one end contains COOH. This is called aldehyde, COOH, aldehyde. So two aldehyde group there on this chemical, this is called glutaraldehyde. So if you mix this glutaraldehyde with this primary antibody, I think make this this is clear more. Yeah, see. So this is the glutaraldehyde, right? So glutaraldehyde one pointed pen. See, this glutaraldehyde is two terminal that contain aldehyde group. COOH, this is called aldehyde group. These two aldehyde group can react easily with the amine group. So amine group and aldehyde group reaction will be there. So some chemistry I am teaching today. Don't be worried. So it is very simple. I'm just some chemistry I am teaching you today. Then again we will come to the sensor device. Because I am teaching you some step by step some formation. So today lots of chemistry, but don't worry, the electrical and mechanical the students, don't worry. So I will come the device part and sensor, the exciting, interesting part I will come again. So amine group and aldehyde group, there is a fast reaction. They can react and you will get on the surface like this. And on this surface, there is another aldehyde, this is called aldehyde. So you are getting another aldehyde group on the surface. Now, if you draw primary antibody, because the primary antibody contain amine group, so this amine group can react with this aldehyde group again, and you will get lots of primary antibody on the surface. So this is just many steps I am teaching you. So which one you like, you can go. So when you will design some biosensor, you can follow any procedure. This is up to you. Which one you like. Some steps maybe you can think about the lots of steps you want to avoid. So you can go just only like you can avoid the APTS formation. You can go for carbon nanotube formation. Or if you like the amine, if you want to form the amine group on the surface, then go for the APTS formation. Which one you like, you can choose. Clear, guys?
Sir, how good is our silicon as sensor surfaces? They are
Okay.
costly, but
Yeah. See, that's I'm saying. Sometimes actually we need amine group. That's why we form the silica content amine group. Sometimes we need carboxylic group on the surface because you know why? Uh, because sometimes we need maybe some gold electrode. Because gold electrode is better for your sensor. Why gold electrode better? That I will teach you again. Means during the selection step, and which electrode is more effective for the sensor. That time I will show you. Sometimes we have to stick on the gold electrode. Then what you will do on the gold electrode? How you will form like carboxylic acids by like carboxylic acid surface, or sometime on the gold surface maybe carbon nanotube is not effectively bind. Just guess. This carbon not effectively bind. Then you have to form somehow some amine group instead of forming the carboxylic group. That's why that time you have to use the APTS. That time you have to use the APTS. Sometimes your surface become that much selective, you cannot use carbon nanotube. That time you have to use maybe APTS. Although it is expensive, but on the sensor, don't think about the price of the chemical. Always. I'm not saying that not don't think. Don't think. I'm saying always. Why? In the sensor, generally we are using very small volume of the chemical. Maybe you are buying 1 gram chemical, suppose it is 1 lakh rupees, right? So you can say it is very expensive, 1 gram, 1 lakh. But in your sensor, actually, you are using 1 microgram per ml or 1 nanogram per ml, very small volume you need. So by the help of 1 gram, actually you can develop or you can fabricate maybe around 10 to 50,000 sensor circuits. So basically then when you count the price of each sensor, then it become around 100 rupees, something like this. Clear?
yes, sir.
Then it become 100 rupees. It is something like this. So that's a sensor. Sometimes we are using very expensive chemical, some expensive bioreagent, but we have finally we have to think of industrial. Means we will develop like a large scale. That time the price is it will automatically go down. Yeah. So it is something like this. Okay. Now come to this is the whole sensor. So this is the whole sensor. See. So okay. So right now I will teach you this one also later. Right now, don't think about this all the step by step. I will teach you again. So this is just think about this is like transducer. Transducer. Now this is a transducer. So on the transducer, you just immobilize APTS, right? So this is APTES, right? You immobilize APTS. So one end is the amine group, right? So on that APTS, you just add glutaraldehyde.
Sir,
Tell me.
sir, what you are writing is actually lagging.
Because of the internet, maybe connectivity, right? I think in our IIT Kharagpur, the internet connection is fine. What about your side? Is internet okay?
Yes, sir, I am getting actual no issues with my.
Okay. Yeah, sometimes because of the connectivity, yeah, when I am writing, you are getting a little bit slower maybe. Later, right?
Yes, sir, that is what happening.
Okay. Okay, then I will write very slowly. Yeah.
Yes, sir.
Yeah. Because the connectivity issue, I understand. So APTS, this one. And on the APTS, we are adding glutaraldehyde, this one. So glutaraldehyde, one surface is the CHO. Okay. Now, this is the antibody, primary antibody 1. So when you are dropping the primary antibody, it can bind on the surface. Okay. Now, when it binds on the surface, then you can add this term. This one is your target. Target or antigen. Please mute whoever not talking or not asking any question. Please mute. Some background noise coming. So so it is your target. See, it is the full biosensor that. So today actually I taught you how to form the full biosensor surface. So this is your, so these things, this is your ITO or a transducer. On the transducer, you can drop the APTS and you can, this is the linker actually. This linker will help you to bind the antibody 1, primary antibody. Now, on the primary antibody surface, you can, now primary antibody here, you can drop your biological solution. That biological solution contain like antigen that will bind on the surface. Now you can wash the surface, then you can go for the secondary antibody that conjugated with the gold, then you can drop all the chemicals that I taught already. Like this way, you can form one complete biosensor. First, make it clear, guys, this one. How we can form a complete biosensor. Then I will teach you slowly how we can choose the chemicals, which chemical is better, why I said the NP, AP, FC, why I said this one. Can we change those chemicals? Okay. So that independently you can think. I will teach you why I am selecting this kind of a chemical. Okay, guys, is it clear until here?
Yes, sir.
Yes, sir.
Okay, nice. Now here, see another slide. Here I will teach you again. Again, here I will show you another procedure for binding the antibody on the surface. So this is antibody 1. You know, here I use BioT, Avidin BioT. So on the ITO is the transducer, the electrode surface, as I say. This is the transducer electrode surface ITO. On that surface, you can drop one protein. It's called Avidin. So you can just drop. And then you can wash the surface. You can wash the surface by using some buffer solution. Even some aqua solution, by some water you can wash the surface. So it's a different kind of buffer composition also I'll let you know later. So just I am teaching you today that on the electrode surface we can drop Avidin. And Avidin, another biochemical, that is biotin. So biotin and Avidin, they have very strong affinity, binding. So if you drop some biotin on the Avidin, they can bind together. This is inherent property there. They can bind together, Avidin and biotin. So how we can use this Avidin biotin conjugation method for immobilizing an antibody on the surface? How? So one antibody can be conjugated with the biotin, with one end of the antibody. So biotin can be conjugated with antibody, and your surface already contain Avidin, right? Your surface already contain Avidin. Now, if you can draw like antibody that is conjugated with biotin on the surface, so it will bind easily. So your surface then will be antibody coated because of biotin and Avidin strong affinity. So this is the another technique. So how we can conjugate antibody on the surface. So on the surface, you can drop some AVD, then you can wash the surface, then on that surface, you can drop some antibody that is conjugated already with biotin. When you drop this one, then incubate, just keep it this solution for around 10 to 30 minutes. That you can optimize which time is better. Around 10 to 30 minutes, you can keep the solution. Then you can wash the solution. Then all the antibody will be there.
So this is for the primary part or the secondary part or both?
Now, this is the primary antibody part I am saying. Okay.
Okay, sir. So
Okay.
I mean to ask that for linking the antibody, this step is for the secondary one also, or just for the primary part?
Which one saying here primary, secondary? It's the antibody. I don't understand.
Yes, sir. Yes, sir. For the antibody,
Ah.
this linking is same for both the part or different?
Say if you can design for the secondary antibody also, you can develop, because by the help of avidin and biotin you can develop something like this. Like for example, you already have primary antibody, you have conjugated this one. So secondary antibody may be conjugated with some biotin, right? And your gold nanoparticle, somehow there are some avidin there on the surface, right? So your secondary antibody can bind with the gold nanoparticle by the help of this avidin biotin conjugation. So your secondary antibody can be conjugated with the gold by the help of avidin biotin. Basically, this is kind of technique I am teaching you. You can apply for primary case also or secondary case also.
Okay.
Clear? Huh. Yeah, something like that. So this is another way for binding the antibody on the surface, or you can use for the secondary case also if you want. And another procedure for binding the antibody on the surface, it is called electrodeposition. Another technique I will teach you, electrodeposition. Electrodeposition, kind of one electrochemical technique. So on the electrode surface, I mean that is already clean. That I already taught you. Your surface can be cleaned by first ethanol solution, then wash it, then ammonium hydroxide, and then hydrogen peroxide water mixture. Then lots of hydroxyl group can be formed on the surface side. Then on that surface, you can immobilize some gold nanoparticle. How you can immobilize gold nanoparticle on that surface? By the help of electrodeposition. So what is the electrodeposition? Electrodeposition technique nothing but some application of the potential, like some negative potential you have to apply on the electrode surface. Negative potential. That is negative potential, negative voltage you have to apply. On which solution you have to take some, like if you want to apply some gold, want to get some gold nanoparticle on the surface, then you have to use some gold salt, like chloroauric acid. This is the gold salt, HAuCl4. So in the gold, this oxidation is the +3 state. When you will apply some negative potential, then some gold nanoparticle will form and oxidation state becomes 0. So chloroauric acid, so you have to take this electrode, and on the electrode you have to take a solution of the gold salt solution. Gold salt means like chloroauric acid. Then you have to apply some negative potential. When you apply some negative potential, then gold will form. হয়ে গেছে না? হ্যাঁ হয়ে গেছে। আচ্ছা, আর 5 মিনিট আমি রেডি করে দিচ্ছি। আমার লোক পালিয়ে তখন কিন্তু হবে। দুজন তিনজন না হলে ওকে, জাস্ট a minute হয়ে করে দিচ্ছি। তাড়াতাড়ি করুন, আমি ওখান থেকে বলছি আপনাকে লোক পালিয়ে তখন আগে নিয়ে করব, একাই তো হবে। আচ্ছা আচ্ছা, শিওর শিওর, 1 মিনিট আমি করে দিচ্ছি। So guys, can you hear me?
Yes, sir.
So today actually I will teach you because so in our office some people are actually visiting today, so I will leave you today. So just this thing I will teach you. Then next class I will teach you again. Huh?
Okay, sir, fine.
See,
Okay.
so some how we can deposit the gold. So first chloroauric acid, then chloroauric acid solution will apply some negative potential. When apply some negative potential, then HACl4 become gold 0. Then gold nanoparticle can be formed on the surface. Okay. Then on the gold nanoparticle surface, now you can immobilize the avidin. This avidin you can immobilize. Then biotinylated antibody you can drop. Then biotinylated antibody will be on the surface. So why you are using that gold nanoparticle on the surface? To make the surface more effective, like more surface area can be high, and electrical its conductivity will be very high because gold nanoparticle highly conductive. Conductivity also will be increased, and your signal to background ratio will be increased also because of high conductivity. The electron can easily be transferred on the surface because of gold nanoparticles. So how we can immobilize gold nanoparticles? That I said that chloroauric acid we can drop on in the surface. Then we can apply some negative potential, and if we apply the negative potential, then this from this salt it will convert it to the gold nanoparticles. Okay.
How this negative potential is applied? What
Their
is the
negative
code?
potential can be applied by the use of one instrument that is called potentiostat. Potentiostat. So here some functionality there. You can apply some negative potential on this solution. Okay. Okay. So this one I will repeat again in the next class. Some people are visiting in my office today. So let's solve this issue here. Then I will teach you in the next class again. Okay.
Yes, sir.
Okay.
Okay. Okay. So I
Okay,
will
sir.
upload.
Okay,
I
sir.
will upload this on MS
Thank you, sir.
MS Office. So please try to. Just a minute. I will take the attendance. I will take the attendance. So please read all the things. Then I will repeat again in the next class. Okay.
Okay, sir.
Okay, sir.
Okay. Okay, guys. Thank you very much. Thank you.
Okay, sir. Thank you.
Thank you.
Thank you, sir.